All right,
The equation is so hard.
it's fine. Look, I'm gonna refer to acids from now on as HA.
HA?
If you see HA, that means they're referring to a weak acid. A weak acid means it will dissociate
Less?
partially. It will dissociate partially. So that means you will do a reversible reaction, H positive with A negative. Okay? Do you get that part? So acids are defined as being able to give away their H ion. Now, the acid, it will be aqueous. The H plus will be aqueous. And the conjugate base we call is going to be also aqueous. So look, HA is the weak acid. And the H plus is the hydrogen ion. And the A negative is called the conjugate base. Okay? Now I'm going to write the Ka expression. No? Did you cover Unit 7?
No.
You just...
How do you use K?
Oh, why just skip Unit 7?
Huh?
Why just skip Unit 7?
I haven't done it.
Or why'd you go to Unit 8 then? Anyways, so... Now, there is something called K with A. K is called equilibrium.
Yeah.
What?
Constant.
Nice. So you already know Unit 7.
Maybe.
Now I'm confused. A means acid. So you must open a fraction, and because everything here is aqueous, you have to use square brackets, with products being on top, and you have two of them, and reactant, which you have one of, in the bottom. So H positive, A negative, HA. Okay? Good? Good. Let's now deal with a base.
So what do you do with this equation?
For now, you have to know how to write it. For later, we're going to be applying it with numbers. Okay. Let's talk about a base. We refer to a weak base as B. A weak base always has to react with water. And you will get BH plus with OH negative. Aqueous, aqueous, liquid, aqueous. Now you should know that we don't put liquids in the K expression. And if I'm doing KB, that means for base, I'll also put products on top and reactants in the bottom. As you can see, I'm not putting the water, because you don't put liquids, you don't put solids. Cool? Aqueous, you definitely put it.
Only aqueous?
Aqueous and gas you put. Cool? Now, that's how you write the K expression and the KB expression. And we only write the K expression and the KB expression for weak species, like a weak acid or a weak base. Never for strong species. Now, so what's the job of an acid? To increase the concentration of the H+, which means to lower the pH. And what's the job of the base? To increase the concentration of the hydroxide, which means to increase the pH. Good. Now, imagine if I had a base like MgOH2, which you should know is a weak base. If it's weak, I'll be using a reversible arrow, which means one going forward, one going backwards, to become ion along with two OH negative. Aqueous, aqueous, aqueous. Now, actually, let's make this into a solid. Now, on the right side, you see hydroxide, correct? You know what that is, hydroxide?
Yeah.
OH negative. Now, if I say that you will take this base and you put it in an acidic solution, what I basically mean, you'll put it in a solution with lots of H plus. And if I were to say you put that thing in a basic solution,
Do I have OH into it?
smart, as a product. Now, question, when H and OH see each other and they react, what do you get? You get water.
Okay.
Now, if something reacts, does it become more or less?
More.
No, it's reacting.
Oh, that's the
Less. So if OH negative sees H positive, it will become less. So OH negative will become what? Less. Correct? So now imagine if you have two plates, one for the left side of the reaction, one for the right side of the reaction. And now the OH negative, which is on the right side, became less, correct? So this plate will now drop. Do you get that part or no?
became less.
Yeah. The right side became less.
Which is which one?
The right side contains the OH negative.
Yeah.
So it became less, correct? So if it becomes less, it will drop. Agree or no?
Yeah.
Okay. Now, the left side is higher and the right side is lower, correct? The left side is the rich and the right side is the poor. Who gives money to whom?
The rich give the money to the poor.
They better. So rich gives to the poor. That means we have to go to the right side.
Yeah.
That means your reaction, you know how it's right now going forward and reverse?
Is this the Lashitier's principle?
Yes, it will go much more forward than reverse. So the reaction will go forward.
It has to compensate for it.
It has to compensate because other guy is poor. You must be the same level
Yeah.
if you're a communist, which I'm sure you're not. But anyways, reaction goes forward. And so the MgOH2 dissolves. Good?
Yeah.
Now, that's called shifting of the reaction. Let's try it again now using a basic solution.
And it doesn't shift.
Now let's take the same reaction and put it in a basic solution, which basically means lots of OH negative. Now, you have a lot of OH on the right side, correct?
Yeah.
So now you have left side and you have right side, and now your right side is more than before.
Shifts to the left.
So the reaction has shifted to the left. Exactly, the reaction shifts left. That means MgOH2, which is solid, will now be formed, which means now it will precipitate. Okay? So MgOH2 will...
What does it mean if something precipitates?
It will go to the bottom of the beaker. This only happens if it has S next to it. S for solid, like a rock.
If it was something else like aqueous, nothing.
You never talk about that.
Alright.
Okay, now we know the shifting part?
Yeah.
Okay. Let's talk about the pH part now. If you want to find the pH of a strong acid, easy. You want to find the pH of a strong base, easy. But weak acid or weak base, you have to actually use the ice table, which means it's a bit more complicated. Let me show you an example. HCl, you have to know, is a strong acid. It will dissociate completely because it's strong into H plus with Cl negative. Now, assume that the concentration of the HCl is 0.010 molar. How much concentration will be the H plus? Are they 1-to-1 ratio?
Yeah.
They are. So the same exact concentration.
So same thing for Cl also?
Yeah. So now how do you find the pH? In the calculator, you will do negative log
For which one?
for HCl. Negative log of the H plus. So a negative log of 0.010.
Is it negative log of H3O plus or is it the same thing?
Same thing. Same thing.
Okay.
So in your calculator, you will find me the number right now.
This is for strong acids and strong bases, right?
For strong acids. For strong acids, base is a bit different.
Oh yeah, strong base is just OH.
Smart. But that's called POH. Okay, now you told me the answer is 2, correct?
Yeah.
That's wrong. You know why? How many figures do you see in here?
3.
Wrong.
2.
You don't count the zeros on the left, so you see 2 significant figures.
Yeah.
And if you're finding pH, you must always add one more figure.
2.0.
Wrong. 2.00. pH always has one more figure.
So this is
So 3 sig figs.
as one more figure.
Yeah.
Okay.
Only for pH and pOH this happens.
Yeah.
Okay. Good. See how easy that was? For a strong acid, extremely easy. Let's do it for a strong base. Let's try NaOH, which becomes Na plus with OH negative. 0.010 molar. That's a 1-to-1 ratio with the OH, correct?
So it's 2.00 again.
For the pH?
For a POH.
Smart. So the pOH
pH
will be
is 12.
exactly.
Do you do 12.00? 12.0?
You do 14.00 minus 2.00
And that would
and you
be
get 12.0. Actually, wait, that's too much. 12.0. Okay? Like, if you had 2 figures, you make it into 3 figures.
Yeah. Maximum 3 or?
No, it's just very common. Okay, that was easy because it was strongs. Let's talk now about weaks. Something like an HC2H3O2. It's a weak acid. Let me give you its concentration, which is 0.20 molar. Let me give you the Ka, which we call the acid dissociation constant, 1.8 times 10 to the power of negative
Ka,
5.
Kb is used for weak acids and weak bases.
Ka for weak acids,
Yeah,
Kb for weak bases. Now the question says, find the pH. You cannot just say negative log of 0.20 because we have to do the ice table.
Which involves a balance equation or no?
Yes, we now have to take the HC2, H3O2 and break it up reversibly into H plus with C2H3O2 negative. This is 0.20 molar.
I draw the ice table.
This is 0 and this is 0 initially.
Initially, minus x, minus x.
Smart. Whoa. What?
No,
What? Only
minus
my.
x,
Yeah.
x.
You mean plus x?
Yeah.
Should do that next time. How about the E?
I have no idea.
Add them up maybe? Very easy, right? 0.20 minus x
Equals.
xx. You only focus on the E part when you build your equation up for the Ka. Because what's Ka? The concentrations at equilibrium. So we're now going to say Ka is equal to products over reactants, correct? What are your products concentration-wise? X times X over 0.20 minus X. Are you with me so far?
Yeah. It's just using the Ka formula.
How much does the Ka replace? So 1.8 times 10 to the power of negative 5. Now there is this unspoken rule that says if the Ka or the Kb...
Wait, the Ka is this?
Yeah, it was given. There's this unspoken rule that says if the Ka is less than or equal to 10 to the power of negative 3, if you have a negative x in the denominator, simply don't count it.
You said Ka less than negative 3?
Less than or equal to 10 to the power of negative 3.
So less than is negative 4.
Negative 4, negative 5, which our thing applies. So ignore that minus 20 in the denominator. Ignore it.
Ignore what?
I mean the minus x, sorry, the minus x. And now what do? We cross multiply and you find the x. So go ahead using your calculator. find the root of 0.20 times this.
Why are we putting it into a root?
Because it's x squared. Gotta find the x.
Forgot simple math.
So let's say you had x squared is equal to 5.
Uh-huh.
And I say find the x, you root the 5. So, right?
Yeah.
Same thing. Go ahead. Tell me the answer, please. So what's the answer?
1.90
No, only two figures.
to the power of -2.
You found the x. The x represents what?
Why 2 sig figs?
Because we only had 2 sig figs and 2 sig figs. The x represents what? The H plus and the conjugate base, correct? So now we know that the H plus is effectively this number. How about the pH? Negative log of that number. Go ahead.
So this whole Ka formula gives you the answer of what?
Of the H plus.
Okay.
One more step to find the pH.
.72 or
Smart. Excellent.
well, that's 3 sig figs instead of 2.
I know, because the pH always
yeah,
have to. Easy, right? Let's do another one. Imagine if I had HClO, which is a weak acid, you have to know, whose concentration is 0.50 molar, whose pH is 1.13. And I say find the Ka. Now it's being reversed on us. They gave us the pH, they want the Ka, unlike the previous question. Here's the trick. We have to first, before doing anything, find the concentration of the H plus ourselves by doing an equation that's not in the equation sheet. 10 to the power of negative pH. Go ahead, do it. 10 to the power of negative 1.13. What are you doing? So 0.074 molar. That's how you start this question. They give you pH, find the H by using this method. Now you're ready to build your ice table. So you can take your HClO.
So 0.074 is the H.
Smart. So you're going to say 0.50 molar 0 ice, which means you will do minus x plus x plus x. But guess what? The x is the H. So replace every x with 0.074. Go ahead, do the math. I'll do it for the ones on the right side. I'll take the hard ones. You do the easy one. Go ahead.
What do you do?
0.50 minus x, so instead of x, put 0.074. Come on, we don't have time.
0.426.
Perfect. Now find the Ka. Products over reactants. So this times this over this. And you get the answer. Easy.
Let me see if I can do that.
So 0.013. You see those two zeros here? They're on the left of a number that's not zero. They don't count.
But the decimal point.
It don't matter. Look, if you had 0.0130, yes, that zero on the right counts.
You just said last time it didn't count.
I never said that. My viewers will agree.
Just
Okay. Let's talk about something new. Something called percent dissociation, which is sometimes called percent ionization. There's an equation for this, which is not in your book and not in your equation sheet. So please take notes. You do concentration of H plus, if you have it, or concentration of the hydronium, if you have it, or the concentration of the conjugate base, if you have it, over the concentration of the acid. And of course, the whole thing has to be multiplied by 100. Okay. Now, when discussing percent ionization, we do it for two types of acids. For something called oxoacid and for something called a binary acid. So what's a binary acid? Two. It has two elements. It has H and a halogen. So it could be HF, HCl.
it has a hydrogen and what?
Hydrogen and a halogen.
Okay. Which is group what?
17.
Yeah.
While the oxoacid will have hydrogen, oxygen, halogen. Hydrogen, oxygen, halogen. Like this.
Okay.
But the O's could be as little as 1 and as many as maybe 4 or 3. So you can have one O or multiple O's. Okay? Yeah. That's the first thing between them, difference-wise. Second thing, for the binary acid, as the atomic size of the halogen increases, the percent ionization increases. So of the 4 listed binary acids, which one has the halogen with the largest size?
BR.
No, I is the biggest. It's in period 5. This one is going to be the most percent ionization.
The higher the period, the higher the atomic size.
Yeah. So HI will have the most percent ionization. The more the atomic size of the halogen, the more the percent ionization. Okay. But in the case of the oxoacids is the opposite trend. We call it electronegativity trend. Of the 4 halogens that you see right here, which one has the most electronegativity?
High. So it would be F. Fine.
Yep. F would be the most electronegative, which means HOF will be the strongest. So in the case of the oxoacid, we look at which one has the most electronegative halogen, will be the one with the most percent ionization. But why? We have to know why.
Why what?
Why is that? Because they're going to ask you in the exam why. And of course, you don't be disappointed, would you? Let's get the why too. So if we're discussing an oxoacid, 2 factors will affect the strength of the acid. The electronegativity of the halogen. So more halogen electronegativity, the halogen, a group 17 element, will be pulling the electrons toward it. So for example, if I have here HOF, that's an oxoacid, no?
Yeah.
The more electronegative the halogen, pulls the electrons toward it. Electrons of the bond, of course. Okay, so the electrons that are in this bond are getting pulled toward the F. When the bond starts to lose its electron density, the bond becomes weaker. The bond will break easier. And if the bond breaks easier, the H plus will be released easier. That's why HOF is the strongest of the oxo acids. Okay? That's why it's going to have the most percent dissociation. The HO bond has the easiest time breaking. H plus leaves, you have an acid. Also, it depends the strength of it on the number of the oxygen atoms. More oxygen we have,
More stronger.
stronger. But why? Because your conjugate base negative charge, conjugate base always negative, but this negative charge now will be more distributed, which means the negative will not be as strong. So the conjugate base will become weaker, and it's going to have a hard time re-attracting the H plus that it already lost. What I said, does it make sense to you or no?
This understanding, no.
Okay, let's imagine it. Imagine if I have HOF becoming H plus with OF negative. It's a full negative re-attracting a positive, not too hard, right? If they do attract, the reaction is now going to go reverse and the acid is going to become weaker because it's not going to dissociate, it's going to actually form. But now imagine if I have HO2F. I'm going to have H plus with OOF. Now what happens is this negative 1, well, it's like having a negative half and a negative half. They're going to have a hard time attracting a plus 1. So the reaction will mostly stay forward. Only some of it will go back, which means the acid will remain dissociated for a longer time. That's better than having only one O. Okay? So if you have more O's, it's better, it's stronger. How about binary acids? The larger size of the halogen makes the bond longer. And if you know from Unit 2, a longer bond means a weaker bond. For example, if I have H with Cl, that's a longer bond than H with F. A longer bond is going to be breaking down easier. How do you get a longer bond? By having a larger size of the halogen.
So Cl is larger than F.
Yes, it is. Cl has 3 shells, F only has 2. Br has 4 shells, I has 5. Also, if you add water to a weak acid, you will result in more acid dissociation. You will. Which essentially means if you are comparing a 0.10 molar acid to a 0.010 molar acid, which one do you think will have more percent dissociation?
The first one.
No, I just said the less concentration. Less concentrated acid has more percent dissociation.
Why?
Because it has more water, it has more movement. Imagine if you're trying to drink honey. Good luck. Good luck. But if you add some water to it, you can actually drink it faster. Now, let's take a moment to understand something. Strong acid, weak acid. If here I have 0.10 molar and here I have 0.10 molar, which one do you think is going to have the lower pH?
The lower pH? Stronger acid.
Exactly, the pH is less. The pH is more. Which one is going to have more H plus?
Yeah, the stronger acid.
H plus is more. H plus is less. If I told you here the pH would be 1.00, how much do you think here the pH will be? Less or more than 1?
It's going to be higher.
Higher. Excellent. Let's draw some Lewis diagrams. So HC2, H3O2. Let's draw it, shall we?
No, but it's the hardest one.
Okay. I'll draw you one thing. It has to have this. Can you draw me the rest? How many carbons are left? 1. How many O's are left? None. How many H's are left? 3. How many dots go on the first O on the left?
The left?
4 dots. How about the right?
6.
4 dots.
4.
Why would you say 6?
I didn't see the 2 bonds.
Do you get the structure?
Yeah.
No. Can I ask you to draw me the structure of C2, H3, O2 negative?
Do you have to do something special and it has a negative?
Well, you have to lose the H, one of the H's. Which H is lost?
The H.
There are 4.
There's 3.
There's 3?
Yeah, 3.
1, 2, 3, 4.
This one?
Well, what do you think? Yalla, come on. Draw it for me, please.
This one?
Yeah, draw me C2H3O2 negative. Look, I will just copy this guy.
How do you know like which one takes priority in the middle?
Carbon always is. And which H of the 4 gets lost? The one that's on the O, correct?
Which H?
This H will go away empty-handed. That means if it had 1 electron, it will stay here.
Yeah.
Now those 2 electrons will become 2 dots. Now find me the formal charge of the O. Do you know what that means?
For what?
You do valence minus dots minus lines. How many valence electrons does O have?
6.
6. And how many dots?
6.
And how many lines? So you get -1 charge.
You asked me for the formal charge of oxygen?
Yes.
And you just take the line that's closest to it?
No, I'm asking for that specific oxygen. Yeah, it has 1 line on it. Not closest, but on it.
Okay. Like connecting to it, nice.
Yeah. Okay, man? Are we learning? This is called the conjugate base, by the way. So when the acid loses the H, it becomes negative. It's called the conjugate base.
When the acid
Loses 1 H, it becomes a conjugate base.
Are you supposed to know this is the acid in the first place?
You were supposed to know that this is the acid. Yeah, you had to know.
How?
There is a list. So here in the document, it tells you the strong acids. There's 6 of them. It tells you the weak acids, like this one, which we just did. This one.
So that was one of the weak acids.
Yes. It tells you the list of the strong bases. Memorization, huh?
Yeah.
A lot of people, you know what they do?
What?
They never memorize this stuff. No idea why. Weak acid. Don't be like them, please. Let's now draw CH3NH2, which is a weak base. Show me. So look, C will be connected to the N. And I'll put the edges. So 1, 2, 3. 1, 2.
Just have to think like
N has how many valence electrons? 5 valence electrons, so 2 dots. A weak base will gain H or lose H?
The question for you is a dot for here, it's a dot for here, and then there's two more dots for the N.
Look, so N has 5 valence electrons, correct?
Yeah.
1, 2, 3,
Yeah.
4, 5. Now, a weak base will gain H or lose H?
A weak base, it will lose H.
Will gain.
Why?
That's what it does. That's its job. It will gain H. But which element gains the H? The C or the N?
The N.
The N, because it has a lone pair.
As
So
a
now
what?
lone pair. And those two dots are called
Oh.
lone pair. So now the lone pair is going to be used to make a bond with the H. Now tell me the formal charge on the N. So the formal charge is going to be
Valence minus dots minus line.
uh-huh.
I don't see any dots.
Okay, so 0 for the dots.
5 and 4.
Uh-huh. So plus 1. Excellent.
Which means something, right?
It's a conjugate acid.
If it's plus 1.
So when a weak base gains an H, it becomes a conjugate acid. Yes.
So the weak base job is to gain H, and then it becomes a conjugate acid.
Smart. Excellent. Let's talk about polyprotic acids. Which are acids with multiple H plus to be lost. Okay? So, for example, if I have H3PO4, how many H's can it lose?
3.
3. But it's not going to lose them in one step, it will lose them in 3 steps. First, it will lose the first one.
This is ionization.
Yes. Well, actually, no. That's losing electrons.
I did this in school. I don't.
Ionization, you guys called it?
Yes. Ionization is losing electrons, right?
Sorry?
Ionization is losing electrons.
Yeah,
Okay.
it is. Okay, so by losing an H, you become negatively charged.
Yeah. You put a H. Yeah, I see.
Now we're going to lose the second H. Now you're going to lose this third H.
And why is the charge changing?
We have to balance the left and the right.
Okay.
Now, which step is the one to easiest lose the H?
Last step.
The first one. Because losing an H positive from a neutral is much easier than losing it from a negative or losing it from a -2. Much easier. Okay? So the first step will gives you almost all the H plus you need. And because it gives you almost the H plus you need, and because it happens so easily, the Ka will be the highest for it.
In the first step?
Yeah. It's going to have a power of -3. Then it becomes a weaker step. The Ka becomes weaker. An even weaker step. So as it becomes harder and harder to lose the H plus, the Ka becomes smaller. Make sense?
Yeah.
Okay. So the Ka will always be the highest for the first step. Okay. Now, which one of these? So look, what do we have right now? We have H3PO4. We have H plus. We have H2PO4. And we have HPO4 -2. And we have PO4 -3. Which one of these is going to have the highest concentration?
What do you mean highest concentration of what?
Highest molarity, I mean.
The first one?
Yes. Whatever you start with will have the highest concentration. I'll call it number 1. What's the second one?
The H.
You know what? Leave the H. Just focus on the ones with the P.
Second one.
Exactly. So the first, the second, the third, and the fourth.
Yeah.
So as you go down, their concentrations goes down with them because the K is going down. Very good. Do you consider this acid a polyprotic acid?
No.
Why? How many H's can it lose?
4.
No,
1.
it can just lose 1
Yeah.
because the H's on the carbon don't get lost. If you can only lose 1 H, it's called monoprotic acid.
So why can it only lose 1? It's because what?
Because only 1 H is on the O and the rest are on the C. H on the C will never get lost.
H and the C will never get lost, and how about the other 3?
Let's draw it. The 3 H's on the left on the carbon don't get lost.
Why?
Because the carbon and the H don't have a big difference in electronegativity, while the O and the H do. Cool? Make sense to you?
Their electronegativity difference is not high?
Yeah, so there's no reason to lose. But the O here just wants to get rid of the H as soon as it can.
Yeah.
So once there's a base, it will take its chance. Now, pH plus pOH is equal to 14. But this will only happen at the temperature of
25.
Excellent. Very good. And also H times OH is equal to this, which again only happens at the 25. Very good.
What does this mean? H plus times OH equals 10. Is that like the...
That's 10 to the power of negative 14.
Okay.
Yeah. This is called the KW, by the way, which is the water dissociation constant. Okay? Does that make sense to you? Should we do... Okay, well, let me just ask you a question. You're nodding, but...
Just show me the things like you're supposed to know with these like equations. What you're supposed to know.
Can you write me the KW expression here? Or is that too much to ask?
Just the expression?
Yeah.
You would do H brackets times OH brackets.
Okay, how about the water?
You will leave it.
Yes, because it's liquid. Thank you. Excellent. Okay.
You said when to not add liquids?
When you write the K expression, no liquids, no solids.
Okay.
Now, Ka times Kb is equal to Kw. So if I know Ka, I can know Kw, Kb, and vice versa.
If you know 2 of the values, you will know the other.
Yeah, because Kw will be given to you in the question or in the equation sheet. Okay. Did you know that water breaks down endothermically?
No.
And do you know what that means?
Endothermically,
Mm-hmm. It requires heat
it requires heat.
to break down. You have to give it energy to break down. So in the case of the endothermic reaction, if you were to increase temperature, which essentially means you would increase delta H, which side would be the rich side?
Which side would be what?
The rich side. Which side is getting the increase, the left or the right?
Right.
How? Delta H is getting increased, which is on the left.
Yes, so left.
Meaning left side is getting the rich side to become the rich side. Left is higher than right. We're going to have to shift right. So more temperature will make the reaction shift right. And if you shift right, more water will dissociate. More H2O dissociates. Now, if more water dissociates, that means you will get more H and OH, correct? I also want you to know one thing. If temperature makes the reaction shift right, the Kw will increase. Only temperature can make the K change. Only.
K in general?
In general. And if temperature makes the reaction go right, K will increase. So essentially, more temperature means more K. More temperature means more Kw, I mean.
In this situation.
Kw is always going to become more with more temperature. No exceptions. Let me give you a small question. So look, if I know that Kw is this much, I want you to find the H plus of the water. Would you know what to do?
No.
Okay. First of all, what was the Kw equation?
H times H positive something times H negative.
Mm-hmm. Now in water, H and OH will be the same. So that means I will replace them as x's. So what's x times x? X squared. You get that part?
Which part?
The x squared part?
Yeah.
Okay. Find me the x, please. So
3.38.
Negative how much?
8.
Okay. Good, right?
That's H plus.
That's H plus and also OH minus because they're the same in the case of the water.
How do you know it's in water?
I told you.
H2O.
Yeah. So more temperature means more Kw. Did you get that part?
Yeah.
Now, if Kw becomes more, pKw becomes less. And if pKw becomes less, pH will also become less.
What does P stand for?
P doesn't stand for anything. P just means negative log. So pH means negative log of H. pKw means negative log of Kw. So when the temperature is 25 Celsius, the pH of the water is 7. When temperature is 100 Celsius, the pH will be less than 7 or more than 7?
It's a good question.
Look,
But it will be less.
if temperature is, yeah, it will be less. And if temperature is 10 Celsius, the pH will be more than 7. Get that part? Now, let's talk about something new. Something called neutralization reactions. That basically means acid plus base. We're going to have multiple types here. We're going to be starting with strong acid plus strong base. So what is an example of a strong acid in your mind?
HCl.
Thank you. A strong base,
NaOH.
let them react. What do you get?
Let them, you will get H2O plus NaCl.
Now, they're going to ask you next for something called the net ionic equation. For a strong acid, you only keep the H positive. For a strong base, you only keep the OH negative. When they react, what do you get?
H2O.
Exactly. This will never change.
That's an ionic equation?
That's called net ionic equation for acid-base reaction, yes.
For only acid-base reactions?
Yes.
Okay.
Yes. Let's try another one. Let's try a strong acid with a weak base. something like an HCl with an NH3 maybe. I only want you to tell me my net ion equation. Which basically means what? For the strong acid, only keep the H plus.
Yeah, so what do you do with the weak base?
You keep the whole thing.
So no difference.
Yep. If it's weak, you keep the whole thing. Reversible reaction because we have a weak. Cool.
Why is it reversible?
Because we have a weak, which is the base.
The weak base?
Weak base or weak acid.
Weak?
Yeah. Number 3. Let's try a weak acid with a strong base. Something like HC2, H3O2 with an AOH.
Do you want me to tell you the ionic equation?
I really do.
So just write the whole.
Write the whole weak acid.
Yeah, plus OH negative, which is a reversible reaction.
Reversible, you mean? Okay.
Yeah, reversible.
What do you get? Good question. Go ahead, say it. What do you get?
HC2H.
H2O with C2H3 or 2 negative.
Yeah, that's what I want to say.
Excellent. Next up, weak acid plus weak base. So HC2, H3O2.
Just write the whole thing.
Just write the whole thing. I'm excited to know what the products will become. Can you please tell us? I'm sure you're equally excited. The H goes to the base. And the acid will become conjugate base.
How do you know?
Well, acids have to lose H, don't they? That's what they're good at. When someone goes gambling, what do they lose?
Money.
Acids lose H. Always.
And then when they lose H, then becomes a conjugate base.
Yes, so the base becomes the conjugate acid, and the acid becomes the conjugate base. And by the way, because the left side contains 2 weak species, the reaction will always favor the weak side. Reaction always favors the side containing 2 weaks. That's a rule, unspoken rule, not mentioned in the book.
What do you mean favors? Like,
look, you know how it's reversible?
yeah.
You can go both right or left. Because you have 2 things weak on the left, the reaction is going to be more going to the left
Because it's 2.
than the right.
Okay.
Okay? More like that. Now, I know we covered the ICE table. Let's not cover the ICC table for this chapter. For example, if I have HCl with NaOH, and I tell you that this is 0.3 molar in 30 ml, and this is 0.4 molar in 40 ml. I say find the pH. Now, of course, you're thinking, are you, that we have to do the ICC table.
I don't know why. When you would use the ICC in the ICE table.
ICE is if they give you K. That's what ICE is, if they give you K.
ICC?
Okay? ICC if there is no K, for the most part. So ICC, yeah, ICC. How do I know? Because there is no K. But the ICC has one issue. It only works with moles. So I'm going to have to ask you to find the mole here and find the mole here so we can start. 0.016. You find me the mole? I thank you for that. Now, we're going to... 1 second, let me just take care of the figures part. You know, we don't want to be wrong, do we? Make it 2 figures here and 2 figures here. Now we're going to have to write the balanced equation. Ready?
Yep.
Okay. So we can write the mole part. 0.0090, 0.016. ICC. Which one of those two reactants is limiting?
NaOH?
No. Which one? Well, which one has less moles?
NaOH. Oh my god, I didn't notice this one.
So it's going to become 0, no?
Yeah.
So we're going to do minus x, minus x. Can you please tell me how much is my x? Are you serious?
Yeah.
No, no calculator.
Negative first number?
Yeah. So x is how much? 0.0090. Do you get why?
Why is it not negative?
Well, no. No, there's negative on the outside. I want the x, pure x, magnitude.
Oh, okay. Yeah.
Okay. You know how it's 0.0090, correct?
Yep.
Now just go ahead and do 0.016 minus 0.0090.
Seven to the power of 10 negative 3.
So like 0.007, do you mean?
Maybe.
Smart man. That's the mole of the NaOH. Am I done yet?
No.
No. Let's now find the molarity of the NaOH.
You don't do anything for a product side?
No, no, no.
Why?
No, that's for something else called buffer, which we'll cover next time. Mole over the volume. But what volume? HCl, NaOH, or both? Both. Because now you put them in one place, correct? So you know those volumes? It's time to now add them up.
Just 70.
70. But make them liter.
0.070.
Wow, what a coincidence. Almost the same number. So what do we get? 0.10 molar. If I know the NaOH concentration, can I know the OH?
If you know the NaOH,
Mm-hmm.
probably.
It's the same. 1-to-1 ratio. Can I know the POH?
Yeah.
1.00. So what's the pH? 13.0.
Good. So the question asks us first of all to solve what?
pH.
Okay, then you put an ICC table.
Mm-hmm.
Why?
Because one of them, because this is strong and strong, one of them has to become 0.
So both of them are strong, so one of them has to be.
Look, whether strong with weak or strong with strong, one thing has to become 0 at some point.
Okay, then you found out the limiting reactor, you just computed the ICC table.
Mm-hmm.
I didn't understand this any OH part.
Well, I want to find the concentration. So I must...
Why of any OH not HCl?
Oh, because HCl became 0.
Oh, okay.
Yeah. So I must divide them all by the combined volumes.
To get the
Molarity.
molarity. What's the formula for this?
Mole over volume.
Yeah. And then 0.10 molarity is the same as.
Yeah, it's 1-to-1 ratio.
And then you found POH and
Easy, right?
too much.
Okay. Let's do another one. So you have H2SO4 plus NaOH, correct?
Yeah.
H will go with the OH. You get water. Na goes with the SO4. Now Na has a charge of +1. SO4 has a charge of -2. They have to exchange. So it becomes Na2SO4. And now if you balance it, you gotta put a 2 in here and you gotta put a 2 in here. When you do your ICC, this will be -x, this will be -2x.
Oh yeah.
Now which one of them is going to become the 0? Did you find that out?
Yeah. NaOH.
Okay. So it's going to become 0 here. Right?
Yeah.
And the mole of it is 0.014. By multiplying these by each other,
Yeah.
the mole of the H2SO4 is going to be 0.035. But how did you know NaOH was limiting reactant? Don't tell me because it's less by looking at 0.014. That's not the only reason.
I divided it by the...
Perfect. Now, using this, find me the x.
0.07.
70. Okay. Now, find me how much is the 0.035 minus x. How much will it be? Exactly 0.028. I think.
Yeah.
I think.
Probably.
Is
Yeah,
it?
it is.
Okay. Okay, so now we know the mole here, and we are going to have 0 mole in here. So now, whatever survived, the pH is going to belong to it. Meaning, because the H2SO4 is the one that survived, the pH has to be less than 7. Correct?
Why?
Because H2SO4 is an acid. So if the acid survived, the pH has to be less than 7.
Okay.
Does that make sense to you?
No.
Look, the base got finished, correct?
Yeah.
So what survived? Only the acid. Acids have what pH? More than 7 or less than 7?
Less.
Exactly. So your answer has to be a pH of less than 7. If it's not, you made a mistake. Now, let's find the molarity of the H2SO4. You would divide the mole
molarity
over the combined volumes. So combine the 0.50 and the 0.70.
because
1.20.
because they're together.
Because they are, yeah, because you're mixing them. Yeah. How much do we get? 0.023 molar. Correct?
Is this H plus?
This is H plus essentially, yeah.
Even for the last question?
Last question was OH minus. So now we're gonna say that pH is equal to negative log
It was OH minus because the one that survived was base.
Exactly. Exactly. So a negative log of 0.023.
That's your answer.
1.64. Okay. Now, there is something new. Something called a buffer solution. And a buffer solution is something that can resist a pH change. Just like a sponge. A sponge can be full of water, but doesn't leak water. It's holding it in. The buffer will resist a pH change. Now, a buffer is made of two things. A weak acid and its conjugate base, or what we call the salt of the conjugate base. It can also be made of a weak base with a conjugate acid, or a salt of the conjugate acid.
What is this salt?
Salt means what? For example, if I have HC2H3O2 as my weak acid, what's the conjugate base? C2H3O2 negative. How salt means canceling that negative charge. So you have to put an element from group 1 to do that. Something like an Na maybe.
And then what will happen?
Let's just call it salt now, because salt is not supposed to have any charge. Or for example, if I take a base, what's the conjugate acid for it?
NH4.
Positive, you mean?
Yeah.
And how do I cancel that positive charge?
By adding something from a negative.
Which is the halogen.
Yeah.
So NH4Cl. That's how it works. Okay?